Team 1 here, ready to present the Fungi Spotlight. The name of this phylum is Chytridiomycota.
The common name of this phylum is Chytrids.
In sexual reproduction, this phylum produces male and female gametangia, which fuse to form diploid zygotes and meiosis to produce haploid spores that can be dispersed to colonize new environments.
In asexual reproduction, this phylum produces zoospores, motospores, that swim using a single flagellum. The process begins with the growth of sporangium, which releases sporangiospores when conditions are favorable. The zoospores then swim through the water to colonize and grow into new individuals. Some examples of this phylum are Chytridium endobioticum, Neocallimastics, and Allomyces.
Fungi as a source of food. Ever since the beginning of civilizations, fungi have been used to produce different types of food and beverages. For example, yeast is used to ferment fruits and grains to produce alcoholic beverages such as beer and wine. It is also used for bread so that it can rise, and for cheese and soy sauce to mature. Not only that, yeast is commonly used in science experiments.
Chytridiomycota are aerobic zoophoric fungi that operate as saprotroph and pathogens in freshwater, brackish, and marine habitats, and are also abundant in soil. Chytridiomycota usually inhabit freshwater ecosystems. In fact, they are dependent on the presence of water to survive. However, Chytridiomycota often dwell within host organisms, which can be animals or plants. They live saprophytically. For example, in pollen grains, insects' exoskeleton, small invertebrates, amphibian skin, and other fungi species of plants, fruits, and waterlogged twigs. They also live parasitically. Chytrids play an important ecological role in the degradation of recalcitrant materials like keratin, chitin, and cellulose.
Pro number 3. Chytrid zoospores as a source of food for zooplankton. Chytrids go through a stage where they're in search of new hosts as parasitic chytrids called the zoospore stage. When they're in this stage, they make for excellent prey of zooplankton for their size, shape, and nutritional value. The zoospores contain polyunsaturated fatty acids along with cholesterol, which are needed for crustacean growth. An example of zooplankton that do benefit from this are zooplankton like the copepods or the cladocerans. They have the ability to grow because they were able to obtain supplementary nutrients from consuming a diet of zoospores. The zooplankton grazing the chytrid zoospores also have an added bonus of suppressing any outbreaks of parasitic chytrids that may cause harm to other organisms. All in all, chytrids, especially in their zoospore stage, are beneficial to the production of zooplankton in the environment.
Many amphibian species are affected by certain chytrids, which can lead to sickness and eventual extinction. Because frogs breathe through their skin, they will have troubles in respiration if the chytrid fungus attacks the keratin-containing regions of their skin. The fungus also weakens the nervous system, which alters the overall behavior of the frog.
Potato wart disease. Chytridium endobioticum is a species of Chytridiomycota that causes potato wart disease or black scab. The disease is characterized by warty galls on a potato stolon, tuber, or stem. This destroys potato crops and reduces their yield. It also makes potatoes unmarketable, which leads to a loss of income for the agricultural sector.
Chytridiomycota is a group of fungi that can have significant environmental impacts. One of the most well-known species is Batrachochytrium dendropatitis, or BD, which causes chytridiomycosis in amphibians and has been linked to declines in amphibian populations worldwide. This disease has been implicated in the decline or extinction of at least 200 species of amphibians, which can have significant ecological consequences as amphibians play a crucial role in many ecosystems. Additionally, amphibians are important indicators of the health of ecosystems, making the impact of BD on them a cause for concern.
Thank you for listening to our presentation. Once again, this is Team 1 signing off.